Dear students, welcome to the Guru lecture of the impact of object orientation in testing. So, impact of an object orientation on testing. The impact of the object orientation in testing can be summarized as follows. Some type of errors could be less plausible. That means very less reasonable. They are not worth for the testing. They are not worth for the testing. Some type of errors could be more plausible, more reasonable. They are worth for the testing now. Okay, we have to test it immediately. Some new types of error might be appear, some unexpected error, some new types of error. Okay, that it's beyond imagination of the tester maybe appear. So these three are the possible scenarios. The impact of inheritance in testing. If a designer do not follow the OOD guidelines, especially if test is done immediately, it will lead with the objects that are extremely hard to debug and maintain. They're extremely hard to debug and maintain. So if designers do not follow the OOD guidelines, especially if the test is done incrementally, it will lead with the objects that are extremely hard to debug and maintain. Uh, the impact of an object orientation on testing, we are going to continue. First, we have to discuss about the reusability of the test. Marek argued that simpler is the test, more likely it is to be reusable in subclasses. Simpler is the test is more likely to be reusable in subclasses. The model developed for analysis and design should be used for testing as well. For example, if you take an inheritance, okay, if your base class contain a method inherited and redefined, two methods. One is inherited, another one is redefined. A derived class redefines a redefined method. What the derived class will do, it actually inherits the method and redefine the method name redefine. So the derived redefined has to be tested afresh since it is a new code because the redefined method is declared in the base class. It is inherited by the derived class. So it is redefine the method. That's why what will happen? The derived redefine has to be tested afresh since it is a new code. If a base inherited has been changed, if base inherited has been changed, uh, then the derived inherited may not have completely tested. For example, you make some changes. Okay, you take another method inherited. The base inherited has been changed. Okay, we make some changes. Then the derived inherited may not have completely tested, where it depends on the base method. Otherwise, it must be tested again. Okay, for example, that the base class is having a two method. One is inherited, another one is redefined. So the actually both the subclass, the derived class, what it will do, it will rework the redefined method. So what happened? We have to test it as a new code in the subclass because it is completely redefined by the derived class. If base inherited has to be changed, okay, we are making some changes. The base inherited, the derived inherited may not have completely tested. Okay, there are not, there's no need to entirely complete test. Only the changes which are made in the base class. Okay, are tested in the derived class. So that is more than sufficient. Where it depends on the base methods, otherwise it must be tested again. Okay, it depends on the base method only. Otherwise it should be tested again. Okay, some major going for a major modification, it should be tested again in the derived class also. It fully depend on the base class method. Impact of the inheritance in testing. We are going to continue. For example, if a non-object oriented system, you are having a method x equal to compute payload. It is a method name. You have to think about the behavior of a single function. You have to think about the behavior of a single function. Okay, where in the non-object oriented system. The same time, in an object-oriented system, you think about the behavior of a base computer payload and a derived computer payload, and so on. For a single message, you have to expose the union of all distinct behavior, which are how it is behaved in the base class and how it behaved in the derived class. Okay, for a single message, you have to expose the union of all distinct behavior. The reusability of the test. If base redefined and derived redefined are two different methods with a different protocol implementation. If base redefined and derived redefined are the two different methods with a different protocol implementation. Each needs a different set of requirements. Okay, each needs a different set of requirements derived from the use cases, analysis, design, and implementation. So the base redefine needs a different set of test requirements derived from the use cases, analysis, design, and implementation, because because they are two different methods. But the methods are likely to be similar. Their set of requirements will overlap. If the methods are similar, okay, they're different, it is okay. They're similar, the set of requirements will overlap. The better the object-oriented design, the greater is the overlap. So in this case, you need to write a new test only for the derived redefined requirement not satisfied by the base redefined test to the object of the class derived. Okay, so in this class, what you have to do, you have to make a new test cases only for the derived redefined requirement not satisfied by the base redefined method. Okay, base defined test to object of the class derived. The test inputs may be appropriate for both classes. The input may be appropriate for both classes, but the expected results might differ in the derived classes. Marik, an expert, argues that simpler is a test. It is more likely. It is to be reusable in subclasses. Simpler is a test. It is more likely to be reused in subclasses. If test is simple, or test case is simple, we can use it to use in the subclasses. But the simple tests tend to find only the false you specifically target. Simple tests tend to find only the false you specifically target. Complex tests are better both finding the false and tentative across others by pure luck. Complex tests are better at both finding those false and tentative across others by pure luck. That means that okay, it is able to find the false, and as well as it able to find other false. Okay, other false are tentatively found by the other simple test method by the pure luck. For example, the class diagram describes the relationship between the objects. Class diagram describes the relationship between the object. That is, an object of the one class may use or contain the object of the another class, which is useful information for testing. Okay, object of the one class use or contain the object of the another class. The use case and high-level class diagram can benefit from the scenario-based testing. Since a class diagram shows the inheritance structure, which is important information for the error-based testing. Okay, if the class diagram is having inheritance structure, it is an important information for the error-based testing. It can be used not only during the analysis but also during the testing. So it can So this it is used for analysis as well as in the testing also. So class diagram, the inheritance structure of the class diagram is an important information for the error-based testing. Okay, that's it for the impact of the object-oriented testing. Okay, we discuss about the reusability, impact of reusability in the testing, and as well as usability test, as well as impact of the inheritance in the testing. Okay, thanks. That's it for the topic. Okay, thanks for watching the video. Thank you.